In this video, we'll try to explore how we can integrate equations by using simple substitution. Now, many given integrands are not readily solvable by direct use of the integration formulas but may be solved by using the simple substitution technique. Now, this involves a change of variable and transformation so that a formula is applicable. And so here, we will study the integration formulas and the simple substitution technique. Now let's recall the power rule. We have the integral of u to the power of n, and then du will just become u to the power of n plus 1 divided by n plus 1. And then we have our constant of integration, as discussed in our previous video. Now what if you have this equation? Let's say we will integrate 3x plus 2 and then cube dx. Now, recall that in order to solve this using direct integration, we need to first expand this term. Now, the problem here arises if the exponent is not 3. Let's say it's a higher number. If, let's say, this is 10, it will be hard to expand. And so, of course, expanding the expression is a tedious computation. And so, the solution of this can be simplified by the substitution technique. Now, if we'll use the substitution technique, we need to convert our function such that we can apply the direct integration formulas. So for this one, we need to treat something as our u. And so let's say our u is 3x plus 2. And so from this, if we will differentiate u with respect to x, we have du over dx is equal to 3. Because if we will differentiate this one, this will become 0, and then 3x will become 3. And then further simplifying this, we have du is equal to 3 dx. And then after this, we need to isolate dx so that we can substitute this one. So we have, multiplying both sides by 1/3, we have dx is equal to du divided by 3 because these will cancel. And so now, we can actually replace dx by du over 3. And then we can also replace 3x plus 2 by the variable u. Now let's just color this one. This is our u, and then this is our dx. And so we can now substitute this one. We have, this is u, and then cubed, and then our dx will become du over 3. And so notice that this function is already integrable because we have our variable u, and then we have du. And then notice that we can apply the power formula. And so let's just rewrite this one. That will become the integral of u cubed divided by 3 multiplied by du. So we have u to the 3 plus 1 divided by, let's just copy this one, that's 3, and then multiplied by 3 plus 1. And then we have plus t. And then simplifying this further, we have u to the 4th divided by 3 times 4. So that will become 12. And then we have plus c. And so now, since we have a variable u, we will substitute this back. And so this will become, let's change back our u, that will be 3x plus 2, and then to the 4th, divided by 12. And then we have plus c. And so this will be our final answer. And so if you want to check this one, let's try to input our function. And then we'll put this inside ddx. So press shift and then ddx. We'll input this function because again, we are doing the reversal of differentiation. And so our original function is actually our answer. And then our given is the differentiated function. And so going back, we have ddx and then 3x plus 2 and then to the power of 4 divided by 12. And then don't include plus c because this is just an arbitrary constant. And then let's input any value, let's say 5, and then we can press equals. Now we have 4913. So at x equals 5, our value is 4913. And so let's try to check if we can get this value if we will substitute 5 into our given. So let's go back here. We have 3x plus 2 and then cubed. And so that will be 3 times 5 and then plus 2 and then cubed. Press equals. We have 4913, which is the same as this one. And so this means that our answer is correct.